So now we're going to look at being able to balance redox reactions that are more complex using the half reaction method. So this method is a series of steps that we will use to systematically balance for both mass and for charge using very specific steps. So I actually find that if you do a couple of these, they're kind of meditative. It's just kind of a nice little system to it, and you always get it right. But let's just start off. So I'm gonna do first a reaction. So you will have a reaction that's Cr2O7 2 minus aqueous plus Cl minus aqueous goes to form chromium 3 plus aqueous plus Cl2 aqueous. So this is unbalanced. And we can see just by looking at the charge, we have, well, actually, we are charged, we are balanced okay for charge because we have a -2, we have a -3 on the reactant side and a +3, but not for mass. And so because of that, we have to, we see here that we have no oxygens on the product side, and so we're going to have to account for that, but we're going to do it in a very systematic way. And so what we're going to do is we first need to assign oxidation numbers and figure out what's being oxidized and what's being reduced. So chlorine has a -1. Again, we've already done this, but we'll do it again. This is -2 for each oxygen. That's going to be -14. We need to have -2 charge. This has to be +12. So each chromium is +6. So if we then look at this side, this is +3, and Cl2 is 0. Now, there's always a really good indication that this is a redox reaction the moment you see an element that goes from anything to whenever you have like Cl2 in its elemental form, or whenever you have a metal as a solid, you know that a redox reaction has happened because it's not going to be a solid or in its elemental state on the other side, so as a reaction or product. And so you know it's had to change its oxidation number. Any reaction in which oxidation numbers are changing is an oxidation reduction reaction. So if we look here, so let's just do chlorine because it's easy. So we can see it's going from -1 to 0. So we have lost electrons to become more positive. So this is losing electrons oxidation. And then if we look at our chromium goes from, hopefully it's being reduced, hopefully it's gaining electrons, going from +6 to +3, so that is gaining electrons. It's being reduced, reduction, okay? And so we then look at, we have to go balance, and so the first thing we want to do is we want to make 2 columns. We'll actually have 3 columns. We'll have our column for the oxidation reaction. We'll have a column for the reduction reaction. And then we're going to have a column for the step that we're doing, what we're actually doing. And actually, I'm going to do this in purple, so it's a little bit clearer. Okay. So the first thing we want to write is oxidation and reduction reaction. So we just put that down. But specifically, we will write, I'll do this in purple. So write half reaction. That's the first thing. And then you want to balance for elements except for, I'll put besides hydrogen and oxygen. So on the oxidation side, so for oxidation, that's going to be chlorine. So we just put Cl minus goes to Cl2. Now I'm going to drop the aqueous and all of these, and I'll put them back at the end, just to save time, because we're going to be rewriting some of these steps. Okay, and then on the reduction side, we have Cr2O7 2 minus goes to Cr3 plus. Okay, so we're going to balance all elements except for our oxygen and hydrogen. So on this side, we have 2 chlorines, so I'm going to put I'll do this orange so you can see the step we're doing 2. And then on this side, we have 2 chromiums and 1 chromium, so I'm going to put 2 chromiums there. Okay, and then the next step we're going to do is our balance for oxygen. So step 1. So the next step is balance for oxygen using water. Like we already said, water is in these aqueous reactions. So it's already in the reaction. We just don't explicitly write it. But we're going to put it in here because that's where the oxygen is coming from. Now you can see that there is no oxygens on the oxidation's half reaction. So we're just going to we'll say we don't have to do it, so we'll put a check there. Now if we look on this side, we have 7 oxygens on the reactant side, so I have to get 7 oxygens on the product. So I'm going to write it a little bit over so we have room. Cr2O7 2 minus. And I have 2 Cr3 plus, and then we're going to add enough waters. So each water has 1 oxygen. We need 7, so 7 H2O. So again, an orange is the thing that we're doing. And so now we're balanced for oxygen. We have 7 oxygens on each side of the reduction half reaction. And so the next step is, well, now we've just added H's to our reaction when we added water that we have to now balance. So we're going to balance for hydrogen using H plus. And so we will do that. If we look here, we have no hydrogens on the oxidation reaction, so we'll put a check mark. And on this side, we have, so we'll rewrite this out, but we can see that we have, let's see, Cr2O7 2 minus goes to form 2 Cr3 plus 7 H2Os. So on this side of the reaction, we have 14 H's. So then we're going to have to add 14 H pluses to the reactant side, so we're balanced for hydrogen. It's okay that one's hydrogen and one's H plus. We'll figure that out in a sec. Okay, so now we should be balanced for mass. We should have the same number of elements on the left and right-hand side of both half reactions. Don't worry, we'll combine these in a sec. And so the next step is going to be, now we're going to look to balance for charge. So we're going to balance for charge by adding electrons. Okay, so now we can finally start doing something on the oxidation half reaction. So we have 2 Cl minus goes to form Cl2. So we have on this side 2 minus because we have 2 minus ions. And so we're going to add 2 electrons to this side. Now we can only make things more negative by adding electrons, so you always have to add electrons to the more positive side to match the negative charge of the other side of the reaction. Okay, to do the same thing here, I'm just going to write this reduction reaction a little below. So we have room for H plus Cr2O7 2 minus. This is how we make mistakes, is if we're not careful recopying. You'll be able to not write out every step after you've done a couple of these. I am, just because we're doing it for the first time, but pointing that out so you can actually save yourself from making mistakes by not having to recopy, because recopy errors tend to be where I make most of my mistakes. Okay, so we look here. I have 2. That's plus 6 for chromium, and so that's the only charge. That's plus 6 on this side. This side I have plus 14, and then we have 2 minus. So on this side it's plus 12, plus 12. And so I need to add 6 electrons to this side, plus 6 electrons. Oh, let's do a little bit better with that. We can do better. 6 electrons plus. And that's going to give us balance for charge. Okay. And now the next step we're going to do is we're going to balance for electrons. We're almost done. Then everything will be balanced after this. Balance for electrons. And so we can see that we have 2 electrons on the oxidation reaction, 6 on the reduction reaction. And so we are going to multiply the side. In this case, we can multiply by 3, and that would allow us to have the right number of electrons. And so we have 6 Cl minus goes to form 3 Cl2 plus 6 electrons. Okay. And now the next step is for this. Now we're going to combine the half reactions. So combine half reactions by adding them up. So the way we do that is we're going to be combining this reaction and this reaction together. And so you're just going to go write down everything on the reaction side first. So I'm just going to start off with oxidation. I have 6, I'm going to do it down a little lower, 6 Cl minus. That's it for the reactants here. So I'm going to go over to here and write all of these out. So I have plus 6 electrons plus 14H plus Cr2O7 2 minus. And then that's it. So I go back to my oxidation and I write out the products. 3 Cl2 plus 6 electrons plus, I'm going to have to write down below. So that's it for the oxidation reduction is plus 2 Cr3 plus 7 H2O. Now what you'll see here is a couple things will cancel. I have 6 electrons on both sides. If that wasn't the case, then I messed up on the previous step where I balanced for electrons. Okay? And then everything else looks to be okay. And at this point, I could simply rewrite this without the electrons. So I'll do that. And we'd be balanced for an acidic solution. So that would be 6 Cl minus aqueous plus 14H plus aqueous plus Cr2O7 2 minus aqueous goes to form 3 Cl2 aqueous plus 2 Cr3 plus aqueous plus 7 H2O liquid. And this would be what we'd say for acidic solution or conditions. And it's called acidic because we have H plus in our solution. Now, that's all we're going to do. You can solve it for basic, but I'm not going to worry about showing you that because very rarely did that ever happen. It's always under acidic conditions. It's just an extra step you need to worry about. So that would be it. That would be done. And that is how we balance. And I guess the one thing we should check is you can go back through and say, okay, have I balanced everything for mass and charge? So we should for charge. We should see that we still have total balance for charge. So let's just do that real quick to make sure we have it. So on this side, we have minus 6 plus 14. That's plus 6 minus 2 is plus 4. And on this side, we have this is, make sure I have this right. We have 2 times, this is 6 plus, let's see here. Oh, sorry, this is plus 6 because we have 2 minus, 8 minus, and 14, that's plus 6. That's why. Plus 6 And on this side, we also have 2 times 3 plus is plus 6. So charge is balanced, and then you can go through and so we have 14 hydrogens, 2 chromiums, 6 chlorines, and 6 chlorines. So we're balanced for mass and charge. Hooray.